Alright, let's change a logarithmic equation to its exponential form, but maybe to get you by if you're struggling. So the first step in this is just the general equation of a logarithm. So a logarithm is generally written like this. So log base b at x equals y. And so a logarithm is the exponent. Logarithms and exponential equations are inverses of each other. So one way I kind of remember how to do these is b is the base of your exponent, y is your exponent, and x is what it's equal to. So I know b to the y equals x. So any logarithm can be converted this way. The beauty in logarithms comes in, to me, in when you solve exponential equations. And I have some videos that show you kind of why we need these and why they're so important to us. But if you're just doing some math problems and you're just trying to get through them, here's the quick way. So one logarithm that's particularly important to us is called the common logarithm. So common log. The common logarithm is a logarithm in base 10. So the common log of 1,000 is 3. So in other words, again, using that pattern I showed you, base is 10 to the third power equals 1,000. So 10 to the third equals 1,000. So if you're doing these problems, they should always check out. Yes, 10 to the third is 1,000. That makes complete sense. Another example. Now, back to common logarithm, sorry. One important thing is it's called the common logarithm because it's base 10. You know, our number system is base 10. So common logarithm on a calculator is just log. In textbooks and in math in general, if you just say the word log of 1,000, that means log base 10 of 1,000. So when there's no number in that subscript of the log, then we assume it's a 10. Just like if you had the square root of 5, or 25, versus the cube root of 25. You know, here we assume there's a 2 if nothing's listed. It's the square root. But if you go beyond the square root, you have cube roots, fourth roots, things like that. So, again, that's maybe off on a tangent, but that's the common logarithm. So, just to kind of recap it, if I did log of 10, well, we know that would have to be 1 because 10 to the first power, here would be the 10, 10 to the first power equals 10. Hopefully that makes some sense to you. If you don't understand exponents, you need to go back and review exponents before you do anything else. Okay, so let's give another example. You know, at this point, maybe stop the video and see if you can do this one. So there's log 3 at 1, log base 3 at 1 equals 0. So see if you can do it. Here's the answer. So 3 to the 0 equals 1. Again, base 3 to the 0 power equals 1. And then one last example. And we know 3 to the 0 is 1. So one last example. Let me extend the page a little here. And let's do one with a negative exponent. So log 5 of 1/25 equals negative 2. So again, if you want to practice this, stop the video, see if you've got this figured out. Here you go. So 5 is your exponent to the negative 2 power equals 1/25. Now this one might be a little tricky if you don't understand negative exponents. So again, if you don't know negative exponents, go back and review that. But to recap it quickly, to me a negative exponent is So 5 to the negative 2 can be rewritten as 1 over 5 squared. The negative exponent inverts the base and the exponent, and it becomes positive. So again, not the place to study negative exponents. That'd be in a different video. So definitely go look that up if that didn't make sense to you. So hopefully this helps you understand kind of quickly at least how to use the logarithm, how to convert logarithms to exponents. In the next video, we'll go the other direction. So good luck. See you next time.